Perfect. Okay, the cube root of 2x plus 1 cubed. What is the answer? Anyone? Exactly. Does it need absolute value? Why? The index is odd. Okay, last one. X squared minus 8x plus 16. And I refuse to help on this one. I'm kidding. But I would like to refuse to help on this one. But I can't. But I will be waiting for you to come up with something. And you can. Please come up with something. With the agreement in front of you, you can come up with something. Make me happy today. Anyone? Splendid. Wonderful. Thank you. Excellent. I am happy. Final answer now. Perfect. Do you all see it? Is it clear? Excellent. Moving on. If the radicand was obtained from positive numbers only, if the radicand is always positive, then there is no need of absolute value for blah, blah, blah radicals. Which type? Maybe I should have written for radicals, blah, blah, blah. Which ones do we ever think of absolute value for? Even. So there is no need of absolute value for radicals with even indices, or even indices radicals, whatever you want to write. For radicals with even indices. So if we are told everything is positive or not, for odd indices, I never use absolute value. But I will not use absolute value for, not even for even indices, if I'm told everything is positive, because it means I don't need. It will be redundant. Okay, perfect. So now let's review the power rules. They are the same power rules for fractions, right? So now I have to use power rules, but this time it's going to be with fractions instead of natural numbers or integers. So what is the first one? A to the mth power times a to the nth power. What is that? Copy the base. What happens to the exponents? No, we cannot multiply. When I multiply, I cannot multiply. So a squared times a to the third is not a to the sixth. Copy the base. What happens to the exponents? I cannot divide exponents unless I have a radical. That's the only time I divide exponents. 2 divided by this. So what is x squared times x to the third equal to? You have 2 apples. I have 3 apples. How many apples we have? Copy the base and add the exponents. The next one, a to the mth power over a to the nth power. M at the top, n at the bottom. Copy the base. What happens to the exponents? Okay, so I have a to the third over a squared. I take 2 away and I take 2 away and I am left with a. So copy the base and what happens to the exponents? What did I do to 3 and 2 to get 1? Correct. M minus n. Very good. A raised to the mth power, everything raised to the nth power. Of course, a here cannot be 0. It's in the denominator. So now I raise an exponential notation to a power. What do I do? Copy the base. What happens to the exponents? Let's say I have a squared to the third power, which is a squared times a squared times a squared, which is a to the sixth. How do I get 6? With 2 and 3. Perfect. M multiplied by n. Next one. AB raised to the nth power. Some students confuse this with this. Please do not confuse these two. This is not a binomial. This is a binomial. It's not the same with this. So a to the nth power times b to the nth power. A divided by b, everything to the nth power. How much will this be? A to the nth power over b to the nth power. How much is a raised to 0, assuming that a is not 0? 0 raised to 0 is not 1. How much is a raised to 0? We have to remember this is 1. So 10 raised to 0 is 1. 15 raised to 0 is 1. Finally, a to negative n. When we have a negative exponent, what type of notation is this? A base raised to a negative exponent. What do I do here? It's a fraction, 1 over a to the nth power. So any base raised to a negative exponent represents a fraction. So now we want to use these exponential rules for x to 1/3 divided by x to 2/5 times x to 1/2. Let's start. So we're asked to use the exponential rules and simplify this expression. What do I do? Where do I start? Well, the top is the top. I can't do anything to it right now. But what about the denominator? Which rule, power rule or exponential rule, I use here? I copy the base. What do I do with the exponent? Forgive me. What do I do with the exponents? We have to go back to what we just read, what we just wrote. I multiply two exponential notations with the same base. I copy the base. What happens to the exponents? Very good. So 2/5 plus 1/2. Very good. Now, forget about this for a moment. Don't look at these two exponents. Just say, I'm dividing two exponential notations with the same base and some exponents. What do I do? Look at the power rules that we just wrote. Copy the base, and what happens to the exponents? From the exponent of the, let's look at the rule. From the exponent of the Are we all looking at this? From the exponent of the numerator, I do what? What is the operation? Subtract the exponent of the, exactly. So from the exponent of the numerator, I subtract the exponent of the denominator. That's the rule. I have to follow that. Perfect. Now what? What is the next step? Copy the base, 1/3, and then what? What do I have to write? Let's distribute -1. What do I write? I'm distributing -1 to these two terms, right? What do I have to write? Very good. Excellent. Good. Now what am I looking for as my next step? Excellent. So let's find the least common denominator. How much? It's okay. 3, 5, and 2 have no common factors. It must be the product. There is no other way. Which is? Excellent. What are the adjustments for each top? What does the top need of 3? Very good. What does the top of 5? Yes. What does the top of denominator 2 need? Excellent. Good. So now tell me what you write at the top of this fraction. It's a lot of work. A lot of work. This, which is 10, minus this, minus 12, and then minus this. Very good. Perfect. So now I have to perform those operations. So I get x to which power? Yes, yes, because I have -27 plus 10, -17. Good. Now I have one more exponential rule to apply. Which one? Look at what we just wrote and say you have to apply this. Which is the last? Yes? Good. What do I write? Very good. Yes. Yes? Splendid. Perfect. Thank you. Now, what is this? A base raised to an exponent that is a fraction. What does that mean? Front page of our handout, very top. Every time I see a base with an exponent that is a fraction, what do I think of immediately? Excellent. So please give me that radical. What is its index? Very good. Its index is? Exactly, the denominator. Perfect. And then the radicand is x to which power? Excellent. Stay with me. I have a question now. I should write a note. Do not, this comes in the next page. Do not leave radicals in the denominator. question is, what should I do with it? Erase it? How do I make it disappear? So here's how I make it disappear. Before we come back here and do something, I need to explain. I have, let's say, the 7th root. And let's say I have here x. What number should I have here in this box or square to get plain x? Okay, if I put 2, then the answer is 2 over 7. So that's not what I want. Let's try again. What should the square contain? And there is only one number that will make this happen. Of course. We're going to think in the same way here. I will multiply and divide by the same number, of course with the same index. And I want you to tell me what should I have in here so that when I multiply this and this, the denominator is just plain x. Think of what you told me to do here. You said only 7 because 7 over 7 will be 1. And then you will figure out and you will tell me what to put in here. They have to be the same because this is 1. I cannot change this. I can only multiply it by 1 in the form I need. So what do I have to have here? The top will be the 30th root of whatever you tell me. But when I multiply these two, I get plain x. And if you think in terms of this, you will figure it out very easily. Say it again.
30.
I can. First of all, it has to have base x. There is no other way. And if I put 30, then this will disappear, but this will not. Right? Because when I multiply these two, I have the 30th root of x, copy the base, add the exponents, 47. And the 30th root of x to the 47th will not work. So 30 will not work. What power will work, which is the only power that will work? What do you think? 17 plus 17 is 34. You're close. I know you're close. So what do I need? Exactly. Exactly. Can anyone explain, other than Heather, why 13 is the only one? Exactly, because when you multiply these two, you will get the 30th root of x to the 30th. Only 13 will help. Copy the base, add the exponents, you get the 30, the index, if you remember, I said that. The index is a dictator here. The index tells me how to choose this. So when I multiply these two, I get exactly this. The 30th root of x to the 30th, which is my x that I'm looking for. This is a very important procedure. You will not see it sophisticated in this class, but it's very sophisticated in the next classes. So this is called rationalizing. Rationalizing the denominator. You could say, and I will have to agree, what did you accomplish? Okay, you made the radical in the denominator disappear, but you ended up with a radical at the top. So what sort of accomplishment is this? A big one. Because, first of all, if these are numbers, this expression will have less error than this one. And you can say, yeah, at the 17th digit, who cares? Well, even if it's at the 17th digit, this will have less error than this one. Secondly, which is more important, you will see that the procedure of rationalizing the denominator helps in simplifying expressions later. So this is the first level that we are learning now about rationalizing. So it's a very important procedure. So let's look at another example, and then we'll go back to the handout. I would like you to tell me, what would you use to rationalize the denominator of this fraction? First of all, which radical would you use? Square root, the cube root, the 10th root? It's all silly. My question is totally silly. Which radical do I have to use? Of course. I cannot multiply the 7th root by the 15th root. It has to be the 7th root. Okay. Now please tell me what we are missing here. How many x's? X squared times x squared will be x to the 4th. I cannot take the 7th root of x to the 4th. X squared times x will be x cubed. I cannot take the 7th root of x to the 3rd. What do I need? Remember what you told me here. Only the 7th root of x to the 7th is x. So what am I missing? If I put 7 here, the x squared times x to the 7th is x to the 9th. The 7th root of x to the 9th cannot be simplified to x. So what am I missing? How many x's do I need? How many x's do I need total, to have total? To remove the radical. Okay, let's try again. The 7th root of x to what is x? Good, I only have 2. How many am I missing? 5. So that when I multiply these two, I get the index. Copy the base, add the exponents. So I have 3 y's. How many am I missing? Exactly. I have 1 z. How many am I missing to remove the radical from on top of it? Yes. Indeed, so then the numerator is the 7th root of x to the 5th, y to the 4th, z to the 6th. And the denominator, I don't even have to look. I don't even have to look. What is the simplified form of the radical? We made it happen. What is it? It's this product. What do I get when I multiply these two? Because I multiply these two to get this. Now I'm multiplying these two. What do I get? Yes? Exactly. That's why we chose this, to get xyz. Very good. Okay, I think we should try one more because we're there close, very close. Okay, here it is. Assume that everything is positive. I'm going to use an even index now. Because otherwise at the end I have to put the absolute value. So, can anyone give us how we rationalize this denominator? First of all, I need a radical. Which radical? Very good, obviously. Then? Right. You mean y to the 3rd? Very good, yes. Perfect. And? Yes, z squared. That's it. So this is the 6th root of x to the 5th, y to the 3rd, z squared, divided by, of course, we made it happen. We calculated, we determined that quantity specifically for this. Okay. Let's go back to the handout. I know I have 5 more minutes. So x raised to 1/2, everything to 4/5. So this is the next problem on the handout. X to 1/2, everything to 4/5. I copy the base. What happens with the exponents? Yes. So 1 over 2 times 4 over 5. I simplify, so I get 2/5. So what is this? I see a radical exponent. What does this mean? It's the what? What does this equal to? First thing we studied in this chapter. First page, first row. Excellent. Good. So let's read the next item. So the 5th root of x squared. Rationalize the denominator, and sometimes we rationalize the numerator. When the denominator has 1 radical, we just looked at this kind of example. And when the denominator has 2 radical expressions, added or subtracted. Okay? So let's rationalize. This is a little bit more complicated. Allow me to choose an easier example as a warm-up. So let's say I have 1 divided by the square root of x plus 2. See the difference? This previous example had only 1 radical, 1 term, nothing added or subtracted. Same thing here, just 1. This one has 2 quantities. If you want, if this is easier for you, we can even put the square root on over 2 to see it. So don't write this because it's wrong, and I'm going to erase it. So doing this, it's not going to work. Because I will distribute here. I meant this, of course. I will distribute here, but I will still have the square root of 2x. So that's not what we need to do now. So then what can I do? So what do I use to rationalize this? I cannot use the square root of, so the square root of 2x and the square root of 2x. Because when I multiply, I distribute here, the radical still stays on 2. And when I distribute here, the radical still stays on x. So nothing of this works. Now I'm going to have to say we signed an agreement. So we have to go back to our agreement. And no, we cannot square the top and square the bottom. Let me explain why. If I say I have 1/2, I can square the top and the bottom and say this is 1/4. I can do that. All of a sudden, I decide to square. I can square both sides of an equation. It's a different story. We will be doing that. But coming back here, what can I do? Let's look at the agreement. In the agreement, we have 2 quantities that are squared, which will not work here. But we also have a 3rd quantity, a 3rd special product. That's what I need to use. What does the 3rd special product say? It says that I have to multiply top and bottom by what? Give it a shot. It's only one option. What do you think? Multiply top and bottom by, you have to look at the agreement. If you're not looking at the agreement, then you will not figure it out. Anyone? I have one, I need the other. What is the other that I'm talking about?
The parentheses x plus 2 close parentheses x minus 2.
Correct. But you are referring to this. Excellent. Yes. So if this is a plus b, I need the a minus b. And what would be the answer in the denominator? When I multiply a plus b by a minus b, or a minus b by a plus b, what does the special product say? What is the answer? In your handout, what is the answer? Just read the answer for me. Exactly. The difference of squares. Exactly. That's what I need. So, again, I don't want to hold you, so we're going to square a. We're going to get x. We're going to square b. And we're going to get 2. And the numerator is as is. We have to talk about this, and then we have to stop here.